I just want to point out that this video is taking a very long time to record, and I don't appreciate it. So if you're staying up late, taking your time to watch these videos, and you don't like them, I'm sorry. Okay, but Unit 3, we're like halfway-ish there. Research methods. Let's do this. The scientific method in psychology. So it's basically saying like systematic observations, measurement, and experiment to formulate and test a hypothesis. This is basically the same scientific method that you learn in like 5th grade, but like applied to psychology. You have to get empirical data, which is like data evidence that comes out of an experiment. The four goals of a scientific method is to describe something, to predict what will occur, to control the factors that will affect it, and to explain why it occurs. There's a hypothesis, which a hypothesis is a specific testable description of an expected outcome. That applies to variables, with variables, anything that'll change the relationship and factors of the experiment. Usually develops from theories. Theories can support them. Methodologies basically shows how you're going to measure the variables, and they have to be like very like observable. There's the operational definition, which you could ask about. It basically talks about how you measure the data collected. So you can't just say, "Oh my God, are you feeling sad? Are you feeling happy?" Because that's not measurable. It would have to be like how many times the kid giggles, how many times the girl cries. Um, yeah, basically. And now we get to experimental method. There are 3 heavy bitches in psychology and getting it. There's the experimental method. The experimental method is basically like literally science. It's the only thing that's going to give you a cause to an effect, a reason why. Don't get them mixed because they ain't the same. It's basically used to cause and effect. Experiment, hypothesis, independent. Okay, there's independent variables, independent variables. Independent variables are the if, so they are what you are manipulating. They're independent from the result because they're the one that are changing. And then there's a dependent variable, which is the then. The researched, what the researchers measure. Dependent variables, they depend on the independent variable to show the results. Population and sampling. Before conducting any experiment, scientists have to get a population. They have to specify what population they're trying to aim, and they must be able to generalize the answers to that population. They have to use techniques enabled to do a valid experiment. You have to have a representative sample, which is basically people who have the characteristics of the population. You have to be careful though, because if depending on how you pick the people, that can lead to sampling bias. That's why it's best to use random sampling, which is getting a big group, getting the population, and random sampling the people and putting them in your pocket. You should be able to have stratified sample, which is when a subgroup, when they're all represented equal. But the issue with that is that it's really hard to basically have every subgroup represented equally. But that's why external validity should be applied, which is where how the answers can apply to everybody. Experimental groups, control groups, and casualties. Not casualties. There's the independent variable connects directly to the experimental group. The experimental group is the one manipulated. The dependent variable connects to the control group, which is basically talking about compare, and there's no treatment. So experimental, you experiment on them, you manipulate them, and control group, you compare them in comparison to the one that you manipulated. You have to have random assignment, which is not the same thing as random sampling. So, you got your population. You random sampled your peeps, and now they're sitting in this corner. And then you're going to randomly assign these peeps into random groups, depending on whomst you want them to be with, but you don't pick that because they're double biased. Experimental design is basically saying all the steps that we just mentioned. Internal validity. You have to make sure that internal validity and confounding variables aren't like a big part of your experiment. Internal validity is basically how the dependent variable influences the independent variable rather than outside factors. All factors can be the same. And confounding variables are influenced things that aren't in the scientist's controls that still affect the experiment in a bad way. Because remember that things should be controlled. They should be very like sterile, super cute, super neat, super. Now, how to control placebo effect experimenter bias. So the placebo effect is basically when you believe that it will happen just because you're told that you're given something. Which is basically like if I give you a sugar pill and then I give you a regular pill and you have a headache and I give you the sugar pill and I'm like, that's an aspirin, you're gonna not get a headache anymore. That's why a better way to solve it is to use single blinded studies, which is where the experimenters don't know that they're being tested, but the scientists do. But the best way to avoid that is double blinded studies, which is when the scientists and the experimenters don't know what's happening, and that eliminates experimenter bias, which is when the scientist affects the people. Research participant bias is basically people act specifically to please the researchers. Now a different type of study. So we just gave you experimental method. Now we're going to correlational. Correlation. Correlation does not mean causation. Never forget. It's basically if there's a relationship among different variables. It's how they can change together. Correlation does not mean causation. There's positive correlation, there's negative correlation, and there's illusory correlation. Positive is that they change together, so if one goes up, the other one goes up. Negative is when inverse, so if one goes up, one goes down. And illusory is that they have no connection at all. Correlational coefficient is the relationship between two variables numerically. It's important to have correlational studies because it helps predict an outcome. Remember, it does not mean causation. I'll slap you if you don't touch causation. The bad thing about correlational studies is that they don't show who affected who. They just show that there was an effect. They don't show what happened. This created the third value problem, which is basically that there could be a third value. There could be a third variable affecting the two that are being tested. Now, next one, descriptive research. Next one, descriptive. You are describing the research about. This basically allows research to experiment. So you are experimenting, but you're still not showing causation. There's naturalistic observations. You observe people in their natural environment. Alright? Like, for example, you look at animals, you look at babies in the classroom. Descriptive basically it shows the meaning of the phenomenon and how often it occurs. It can reveal information about others' behaviors and attitudes. And it tells you the subject's interest, just it doesn't tell you why. It must be systematic, and you have to know who you're observing, when and how they're being observed. The different type of descriptive research is case studies, which is going to look at a specific case over a long period of time in order to show how it is going to relate to the other people. Whatever. And then there's survey and interview. Surveys when people get a list of questions, they have to answer them. The downfall of that is that people can lie with them very easily. And then using random selection is going to eliminate the bias of giving it to only a certain amount of people. Interview is basically asking people questions. Results can lead you to know, opinion, experience, feelings, emotions. There's subjective self-report, which is basically when you want to look nice. There's demand characteristics, which is when you act like you want them to act. And then social desirability bias is basically when you want to be nice and empathetic. Developing research design. Basically, the longitude of the design shows that someone overlong. Compare group based on age. Okay, so research design is stupid. Cohort effect is basically being a part of a group confused with living age. Whatever, it's stupid. Ethics guidelines for psychology research. Ethics. You must follow the IRB, Institutional Review Board. She'll hunt you. There's informed content. Let me go to the. There's a whole thing for ethics in the back, I think. Statistics and statistics. You have to think critically about your stats. You got a data set and you have to interpret it. Stats can help you when you look at an outcome. It's basically interpreting. There's descriptive data, which is organizing and describing data sets. It's easier to manage and see patterns. There's frequency distribution. Frequency distribution tables are helpful when showing how often things happen, which basically can help you see. It helps you not overlook data. It shows the frequency. Types of data and scales and measurements. There's discrete data and there's continuous data. Discrete data it can't be further divided, and things you can actually count, so like number of swings. And there's continuous data, is data that you can measure rather than count, so like height. So let's look at like this tree. There's quantitative data, which is data of numbers, quantities. Then there's discrete data, and there is continuous data. Discrete data talks about nominals, which is categories of data, which talks about numbers, and then ordinals, which is ranking in order. So there's discrete data, which was counting. There is nominal, which is naming, and then there's ordinal, which is ranking. And then there's continuous data, which is, remember that was like things that you can actually measure. There's interval, which is you rank in order and in equal measures between each order. And there's ratio, which is in all of them combined. Displaying data. So there's different type of charts. You have to know which chart to use when they ask you a question. So there's pie charts. Pie charts are use nominal data, and they categorize using percent and proportion. Bar graphs are categorical. They're non-numerical. They show frequency and nominal data. So bar graphs show frequency. Histograms show continuous data. So histograms are basically bar graphs but with continuous data. Frequency polygons are continuous data measuring intervals or ratios. I don't get that number. Measure of control tendency. Measure of control tendency. There's the mean, median, the mode. Median at the mod divided by the total. Median the center number. Mode is how often things happen. Measuring variables. There's the range, which is the highest minus the lowest. There's a variable which variant how spread things are. There's using standard deviation. Standard deviation, girl, no. Standard deviation is the distance from the mean to a set of scores. Using a z-score, which is like a thing, it's the number of standard deviation to the mean. Is this a thing right here? Yeah, per. It basically gets the mean, so it tracks it. But yeah. Normal distribution. So there's different types of distributions. There's normal, which is basically like the symmetrical one, the one that's like it's basically like a bell curve, but not really. It shows percent rank, which is how far off they fall from the mean. Outliers, which they don't really like out, girl. Then there's skewed distributions. Skewed distributions. There's positively skewed, which is to the right, so that's. And then there's negatively skewed, which is. Isn't that easy? Positively skewed. The tail is to the right. It's usually the mode and then whatever. Result of correlation of studies. There's three different types of correlation. There's positive correlation, negative correlation, and illusory correlation. We kind of talked about them over there, but they have this specific way of showing them. Positive is so positive is like this, negative is like this, illusory is like that. If you want to see the actual graph, those are the graphs. Inferential statistics, which is basically interpreting data and how things are going to happen due to the manipulation of the independent variable. Statistical significance, blah blah. Meta-analytic, which is getting a bunch of research results and analyzing them, like meta, like girl, like that's like the one job. I think that's all we have to know. Oh wait, ethics. For ethic, here you go. Ethic guidelines. So there's this. Do you remember the IRB that I mentioned before? She's gonna come back to you. So the IRB, there's the Institute of Technology. They make sure the experiment isn't like posing at risk. So, number one, they must be informed and consent. Informed consent. Basically, they have to be informed. They have to be like, yes, I am down. And if they're not informed, it has to be only for the benefit of the research. Basically, you can't force a person to a study. Coercion isn't allowed, which is basically people can drop out whenever. They can't be forced into it. They, for patients, blah, blah, informed consent form. They must sign an informed consent form unless blah, blah, blah. Deception. They can't be deceived unless it's for the better of the study. Deceived is basically when you mislead a person in order for the experiment to work. Example is the middlegram study, which I'm not going to get into because she's complicated. It must be approved by THEYRE if you are going to mislead. You can't lie about the risk of a study. You can't falsely, result to this. I don't know. You can't, you must? Yes, you must debrief the participants. Debrief basically means telling them like what's going on. And you can't make emotional or well-being damage to the participant. That's a big no-no. If you do, you have to pay the fudge out of them. Confidentiality and anonymity. Basically, people have to stay. Their identity has to stay intact. You can't be telling people who they are unless they agree. Animal research. They have the whole they have their whole life. They have the Animal Care and Use Committee, which is the ACUC, and the Committee on Animal Research and Ethics, which is CARE. They basically say the guidelines you shouldn't abuse animals. They basically follow the same ethics, but a little bit more they're a little bit more fake because animals. But yeah, fetch me. Yes, I just broke a page. I just broke a page. That was Unit 3. We have 4 more to go.